Hello students, welcome to Biswas tutorial. Today we are going to start a topic which is about salt. Previously we have completed the topic acid and bases. We have learned the physical and chemical properties of acid and bases. Along with it we have also learned what is pH and what is the pH for an acid, what is the pH for a base, what are strong acids, what are weak acids. We also have learned what is weak base and strong base. Clear? If anything is not clear, please go through the previous videos that I have made. I think they will be helpful. Today let us start a topic which is salt. In the previous videos we have learned about a neutralization reaction, where we have learned that when an acid reacts with a base, it gives us salt and water. So when we study about salt, we first come to the base reaction of neutralization reaction, which is acid when reacts with a base, it gives us salt and water. Clear? Now let us see some of the acids and also the reactions, how the formation of salt is taking place. Let us take first of all an acid which is HCl. HCl when reacts with NaOH, a base, it leads to the formation of NaCl plus H2O. Clear? When an acid HCl reacts with a base NaOH, it gives NaCl and H2O. Moreover, when we take the same acid and react with another base MgOH2, we observe the formation of MgCl2 with the liberation of water. Clear? So we can see that if we take hydrochloric acid, then we obtain a salt that is chloride. We obtain a salt which is chloride salt. You can see over here, this is chloride and this is also chloride. This is sodium chloride and magnesium chloride. So we can see that if we take hydrochloric acid, we obtain chloride salts. Okay, the salts will have chloride. Now let us take one more acid, say H2SO4. H2SO4 when reacts with NaOH, they give us Na2SO4 plus H2O. Over here we can see sulfuric acid when reacts with the base, they give sulfate salts. This ion is sulfate. Okay, now we need to balance it. Okay, I hope it is balanced. Now let us see one more reaction of sulfuric acid. It reacts with the same base that we have taken before, MgOH2, to give magnesium sulfate, MgSO4, with the liberation of water. Okay, with the liberation of water. So over here we can see that hydrochloric acids leads to the formation of chloride salts, sulfuric acids leads to the formation of sulfate salts. Let us see one more acid, say HNO3. Say we are taking HNO3. When it reacts with NaOH, it leads to the formation of NaNO3 plus H2O. NaNO3 plus H2O. Again, let us take one more example. HNO3 when reacts with NaOH, we are taking the same salt. When reacts with MgOH2, which is another base, it leads to the formation of magnesium nitrate, MgNO3(2), with the liberation of H2O. Now here we can see that if we take one more acid, let us say we are taking H2CO3. This is carbonic acid. Okay, when reacts with NaOH, it leads to the formation of Na2CO3 plus H2O. Okay, again if we take H2CO3 and react with MgOH2, we see the formation of MgCO3 plus H2O. Okay, MgCO3 plus H2O. Okay, so very clearly we can observe that several acids, they react with bases to give salts. Okay, now we can observe that when hydrochloric acids, they react with bases, they give chloride salts, sodium chloride, magnesium chloride, and any other the bases. It depends upon the base that we take. Okay, now when we take sulfuric acid, we see that they react with bases to give sulfate salts, sodium sulfate, magnesium sulfate. And we take nitric acid, we see the reaction with bases to obtain sodium nitrate, magnesium nitrate, nitrate salts. Moreover, when carbonic acid, when reacts with bases, they give sodium carbonate and magnesium carbonate. So it is clear from the observation that this particular chloride, sulfate, NO3, CO3 is coming to the salt, is coming in the salt. Okay, now we will erase this part and we will see what is the ion that is coming from the acid and what is the ion coming from the base. Here only it is clear to you. See here, if you take the first reaction, HCl and NaOH, you can see that Cl in the salt comes from the acid, whereas Na in the base comes from the base. Okay, we are going to see that now. Now let us take the several acids and see what are the ions that are dissociated. We are taking H2SO4 and we know they dissociate into two H plus ions and SO4 2 minus ions. Okay, and if we take a nitric acid HNO3, they dissociate into H plus ions and NO3 minus ions. If we take HCl, they dissociate into H plus and Cl minus. And if we take your H2CO3, they liberate 2H plus and CO3 2 minus. So acids, they dissociate to give H plus ions. We have studied it. And they give a acidic radical. The radicals that are other than H plus, they are actually your acidic radical, or you can see acid radicals. Okay, these are acid radicals. Now in case of base, we can see we have taken two bases, NaOH, they dissociate into Na plus, they dissociate into OH minus plus Na plus. Moreover, MgOH whole 2, they dissociate into OH minus, giving out Mg2 plus. NH4OH, okay, they dissociate into OH minus plus NH4 plus. You can see that other than the hydroxide ion, that is the property of base, the radicals that are obtained from the base, they are actually basic radicals. They are basic radicals. Okay, now acidic radicals, you can see, have a negative sign. Okay, acidic radicals, they have a negative sign. So they are electronegative. They are electronegative in nature. Okay, whereas you can see basic radicals, they are having positive charge. Okay, and hence they are actually electropositive. They are actually electropositive. So what happens when these acids, they react with certain bases, this H and OH, they come in contact, leading to the formation of water. But despite the water that is formed, we know one more substance that is formed in the acid-base reaction, which is your salt. We can see the acid radicals react with the basic radicals to get a salt. Now we can say when a salt is prepared, the electropositive part of the salt is obtained from the base. They are actually bases. Okay, and in a salt the electronegative part is obtained from the acid. The electronegative part is obtained from the acids. So you have to make it clear that acids, when react with bases, they give away their electronegative radicals, which are the acidic radicals, which combine with the basic radicals or the electropositive radicals and combine together, leading to the formation of salts. Clear? Now we will observe the different hydrolysis of salts, and we will try to find out from which acid and base a particular salt is obtained. So we can do it by a process which is called hydrolysis of water. Let us see. Now let us take some salts which are, say, NaNO3. This is sodium nitrate. Now Na2SO4. This is sodium sulfate. Now NaCl. This is sodium chloride. Na2CO3. These are sodium carbonate. Okay, now we have to find out from which acid and base are this salt produced. Now we can see this particular salt, which when dissociated in water, we can obtain what? The acid or the salt. What we will observe, that we will see the formation of NaOH. Actually, the electropositive part of this salt forms the base. So we are reacting the OH part of water with the Na+, and we will obtain H+ with the acidic radicals, and we get HNO3. We mean to say that the electronegative part of this salt comes from the acid, whereas the electropositive part, which is the Na+, we can write this as Na+ NO3 minus. So you can understand now, this is the electropositive part and this is the electronegative part. Okay, now we can see the electropositive part comes from the base, whereas the electronegative part comes from the acid. We are going to see similarly in these reactions. We can see here we have 2 Na+ ions and SO4 2 minus ions. When they react with your water, they leads to the formation of, now see, this is the electropositive part, so we will obtain NaOH plus H2SO4. Over here we will see when reacted with water or when hydrolyzed with water, we obtain NaOH and we obtain a particular HCl. Okay, we obtained HCl. Now we are not balancing it. Okay, we are just taking out the acids and bases that by which this particular salt is made of. When we are hydrolyzing sodium carbonate, we see the formation of NaOH and H2CO3. So from this particular part, we can understand a salt has a particular electropositive part and a particular electronegative part. Over here the electropositive part is Na plus and electronegative part is Cl minus. Over here we can see it is Na plus, 2 Na plus and CO3 2 minus. So in these reactions we can see that the electropositive parts comes from the base and the electronegative part comes from the acid. Similar occurs in all these reactions. Okay. Now we will observe that all these particular salts, okay, they have a particular ion in common. You can see the sodium ion. You can see they have sodium ion in common. Okay, so this particular salts will be called as sodium salts. In this way we distinguish the particular family of salts. If we see MgNO3, MgNO3 whole 2, MgCl2, MgSO4, or we can say MgCO3, these are actually magnesium salt. These are actually magnesium salts. Okay, now the salts that have a particular ion in common, over here we can see these salts have sodium ion in common, so they are called sodium salts. Over here we can see all the salts, they have magnesium ion in common, they are called magnesium salts. Clear? Now if the salts that are prepared from hydrochloric acid, they are all chlorides. They have chloride ion in common, they are called chloride salts. Now when we react a particular base with sulfuric acid, you have seen earlier that sulfuric acid leads to the formation of sulfate salts. All the salts that are formed by sulfuric acid will have sulfate ion in common, and hence they will be called as sulfate salts. Okay, so far what we have studied, let us recapitulate the part. So we have studied that acid, when reacts with a base, they give salt and water. Okay. Now sulfuric acid, when it reacts with a base, they give sulfate salts. All the salts will contain a particular acidic radical, that is SO4 minus, that is obtained from the acid. Okay. Again, when hydrochloric acid reacts with a salt, they give chloride salts. When nitric acid reacts with a base, they give nitrate salts. When carbonic acid reacts with a base, they give carbonates, carbonate. Okay, so this was the part where we see that acid reacts with the base to give salt. The several acids, they give several acidic salts. Sulfuric acid gives sulfate salts, hydrochloric acid gives chloride salts, nitric acid gives nitrate salts, carbonic acid gives carbonate salts. Again, we have also noticed that an acid dissociates into H plus ions and electronegative ion, and this is electronegative. Why? Because of having a negative charge. So we can see an acid, it dissociates the H plus ions and gives the electronegative acid radical, whereas a base, they dissociate into OH minus ions and electropositive radical. They are electropositive. Okay, electropositive in nature. So this acid and bases, we can see acid liberates the electronegative ion, bases liberate the electropositive ions, and this electronegative and electropositive ions, they attract each other, leading to the formation of a salt. Okay, we can see several salts like Na plus when reacts with sulfate ion gives Na2SO4. Okay, Na plus when reacts with Cl, they give NaCl. Okay, when Na plus reacts with nitrate, they gives nitrate salts. We can also obtain the different acid and bases from which a particular salt is prepared. We know that the electronegative part is obtained from the acid, whereas the electropositive part is obtained from the base. We can see the several hydrolysis of salts where we can obtain the respective acids. Okay, now we will go forward to see that sometimes in salts also we can see there are some salts that are neutral in character, that does not change the color of litmus, whereas there are some salts that behave acidic character, or they turn blue litmus red, and there are some salts that turns red litmus to blue, behaving as a base. We are going to discuss the next topic about the pH of several salts, how they are, how the acidic salts are obtained, and how the basic salts are obtained, and how even the neutral salts are obtained. When we are discussing about the pH of salts, we must recall strong acid, weak acid, and strong base and weak base. Okay, we know that acid and bases, they react together to get a salt. Now when a strong acid reacts with a strong base, so here we can see that they will lead to the formation of neutral salt, and with the liberation of water. The amount of H plus ions liberated by the strong acid and the amount of OH minus ions liberated by the strong base, they neutralize the acidity and basicity to form the neutral salt. Okay, let us see one example. We can see that HCl, a strong acid, when reacts with the NaOH, a strong base, they result to the formation of NaCl plus H2O. So NaCl, that is obtained from a hydrochloric acid, a strong acid, and NaOH, sodium hydroxide, a strong base, they lead to the formation of a neutral salt. Moreover, when we take a weak acid and a weak base, we will also find a neutral salt. We will also find a neutral salt. Okay. Now weak acid releases less number of H plus ions. Weak base releases less number of OH minus ions. They two counter each other and neutralize the acidity and basicity. Let us see a weak acid, say CH3COOH. When reacts with a weak base, let us talk about a weak base which is NH4OH. When they react with each other, they give a particular salt which is ammonium acetate, CH3COONH4 minus plus, and that leads to the formation of H2O. So ammonium acetate is also a neutral salt because it is obtained from a weak acid, acetic acid, and a weak base, ammonium hydroxide. Now let us talk how the salts are becoming acidic and basic. It is very interesting and it will be very easier to know that if we take a strong acid, when reacts with a weak base, we get a acidic salt. Plus H2O. So let us see an example. We take a strong acid, say HCl. When it reacts with a weak base, NH4OH, it leads to the formation of an acidic salt which is NH4Cl and the liberation of H2O. Now we can say here that a strong acid releases large number of H plus ions, whereas a weak base releases less number of OH minus ions. So in comparison, the H plus ions remain in excess and the formation of salt leads to the acidic salt. Let us see the formation of basic salt. In case of basic salt, what we take, you also can understand that if we take a weak acid and react with a strong base, we lead to the formation of basic salt. With the liberation of H2O. Let us see an example. A weak acid, a CH3COOH, when reacts with a strong base NaOH, it leads to the formation of sodium acetate salt, which is a basic salt, which is CH3COONA. We can write here the negative and the positive signs. COO minus, that comes from the acid, and Na plus comes from the base, leading to the formation of H2O. So let us recapitulate all about the pH of salts. What we see that when strong acid reacts with a strong base, there is maximum amount of H plus ions and maximum amount of OH minus ions, and hence they neutralize each other to form a neutral salt with the liberation of water. Again, when a weak acid reacts with a weak base, okay, there is less number of H plus ions from the weak acid, and there is less number of OH minus from the weak base. They result in the neutral salt. But when we take a strong acid reacted with a weak base, here the H plus ions are larger in amount, but the OH minus ions, because it is a weak base, is less. And hence what we find in the acidic salt, there is a pH less than 7. It is because the H plus ions in the strong acid is greater in amount and leads to the formation of acidic salt. Similarly, if we take a weak acid which liberates less number of H plus ions and react with a strong base NaOH with a greater number of OH minus ions, we will see the salt that will be prepared will be having a basic character. So this was all about the family of salt. We have seen the salts that are having same ions are belong to the same family, like all the sulfate salts are obtained from sulfuric acid are called sulfate salts. All the chlorides are obtained from hydrochloric acid are called chloride salts. Moreover, all the salts that have sodium in common, like sodium chloride, sodium sulfate, sodium carbonate, they all have sodium in common. They are called sodium salts. Again, we have also learned that acid liberates the H plus ion with a electronegative radical, which is the acidic radical, whereas a base, they liberate the OH minus ions with the electropositive part, that is the basic radical. The acidic radical of the acid and the basic radical of the base, they react together and combine to form the salt. Okay. We have seen several salts earlier. If you have missed somewhat, please see the video again, you will understand. Over here we have seen the pH of salts. It is very easy to learn that strong acids react with strong bases to give neutral salt. Weak acid react with weak base to give neutral salt. Whereas if strong acid react with a weak base, it gives a acidic salt, and when a weak acid reacts with a strong base, it gives a basic salt. Okay, this was the introduction to salts. I know it is a quite large topic. Please go through the video. I hope it will be very much helpful to you to learn about the different aspects of salts. In the next video, we are coming up with the common salt NaCl and its compounds. We will try to finish the chapter. Okay, hope if you are going through the videos, you will be very much helpful for your CBSE class 10 exam. If you like the video, please give a click on the like button and subscribe the channel and share among your friends. Thank you.